Morning, everyone. Welcome, and thank you for attending this important session. In the meantime, make yourself comfortable and ensure you have good internet connection and that your laptop or phone has sufficient charge. During the webinar, please type your question in the Q&A feature, which will be answered by the resource person. You can also raise your hand to speak in the slot for the question and answer. And also all the presentations and recording, they will be available after 12 hours in our website. Thank you all, and thank you for joining this important session. Again, and on behalf of the Executive Director of the Nile Basin Initiative Secretariat, Engineer Silvista Matemo, I would like to thank all the panelists and welcome all the participants on this important webinar, which is about strategic water resources analysis, a planning tool for meeting multisectoral water demands in transboundary river basins. The Nile Basin Initiative, in collaboration with the government of Uganda, is organizing a series of webinars in the 7th Nile Basin Development Forum. The Science Policy Practice Dialogue is organized to bring together MBI with its stakeholders from Nile Basin countries and around the world. The theme of this forum is deepening Nile cooperation, accelerating the achievement of SDGs in changing climate. The goal of the 7th Nile Basin Development Forum is to enhance transformation processes in projects that will contribute to the Nile Basin Initiative shared vision. And the shared vision is to achieve sustainable socioeconomic development through the equitable utilization of and benefit from the common Nile Basin water resources. The themes under this 7th Nile Basin Development Forum are adaptation to climate change, water supply and sanitation, water resources management, basin investment plan, groundwater, water quality, transboundary water governance. The Nile Basin is one of the most critical transboundary water basins in Africa, with the River Nile playing a crucial role and source for the most economic and social activities for the countries in the Eastern and Northeastern Africa. Welcome all to this important session about strategic water resources analysis, and we hope that different presentation will provide valuable insights and help in making informed decisions regarding strategic water resources analysis. Let us have fruitful presentations and discussions, and let us work together to incorporate these findings in our decision-making and river basin agenda. Thank you. And our moderator for this session is Professor Joel. Professor
Hello.
Joel.
Yes, I'm here.
Okay, excellent. Thank you, Professor Joel. So Professor Joel will moderate this session. And after that, we will have a Q&A session. And finally, we will have a panel discussion. And then we will wrap up this important morning session. Thank you. Professor Joel, please introduce yourself. And the floor is yours. Thank you.
Okay, thank you very much, Dr. Mudadir. So my name is Joel Nobat. I'm from the University of Dar es Salaam, and I'm specialized in hydrology and water resource management. I've been working in the areas of water resources planning and analysis, and also hydrological modeling in different catchments in Tanzania. So I've also had time to work also with the Nile Basin for some projects as well. So that is me, and I'll be moderating this session today. So we have, I think today we have around 7 presenters, I think, if I'm not mistaken. Yeah, Mudadir, that is me. So I'm not sure if I should continue straight away or take it back to you first.
Yes, just allow me to recognize The expert here in the room, we have our Deputy Executive Director and the head of the Basin-wide program, Dr. Michael Kiza. We have Marushka, we have Vincent, we have Tom, we have our young professionals, we have Mr. Alain, Dr. Azza, and Mr. Sued. All these experts, they are here also from the MBI side. Back to you, Professor Joel. Thank you.
Okay, thank you very much, Dr. Mudadir. Yeah, so as I said, I think today we have full house. We have 7 presenters. We have Mr. Oluf Jensen, and he's in the house already. We have Professor Hubert Lohr. We have Dr. Mohamed Bashir. Mohamed, I think you're also in the house already. Mohamed?
Yes, I'm online. Yes.
Thank you very much. And then we have Dr. Emmanuel Arasa. Are you also around? Mr. Dr. Emmanuel, are you online?
No, not yet.
Not yet. Okay. Then we have Engineer Gebehu Baharu. Not yet online.
Yet also.
And then we have Mr. Habtu Moges. Not yet also, probably. And then Gashau and Ayala Lu. Okay. Now I think they will join as we continue. Then I think we can start straight away.
Yes.
And I think we are going to start with Professor Hubert Lohr. I need to be guided if I'm right. Dr. Mudadir, is that correct?
Hubert is present.
Yes, good. Yeah, so let me just give a brief bio of Professor Hubert Lohr. Professor Hubert Lohr has a PhD from a technical university, Darmstadt, German, in hydrology and water resource management. He graduated in 1993 with civil engineering degree, majoring in hydrology, water resources management, hydraulic engineering, geotechnics, hydrogeology. Hubert combines expertise in water resource management, cross-sectoral analysis, local knowledge, and technical skills related to modeling and data management. Hubert has vast experience in shared river basins and has been working in the Mekong region, Caucasus, Europe, Southern African region, and since 2016, continuously in the Nile Basin. So that is Prof. Hubert Lohr, and his presentation is going to be on strategic water resources analysis of the Nile Basin Phase 2. Prof, the room is yours. Please do your presentation.
So thank you very much, moderator. Thank you very much, dear colleagues from NBI and all the participants. I just want to start sharing my screen. And if you, please, someone can give me a note whether or not it's working and you see something.
Yes, it's working.
Okay, thank you. Very good. Thank you. So I have the first presentation, and this is about the strategic water resources analysis. In short, in the next slides, you will always see the abbreviation SWRA, and I will also say and refer to the long name of strategic water resources analysis as SWRA. And this analysis assessment, as you will see, was quite a huge process. And just to let you know about a little bit of the background, it started in 2015, actually, and then I was a concentrated phase of a couple of years. Then there was a break due to the change of the modelers and to the change of the responsible people. Then we came in quite late to continue and to fulfill and to serve the finalization of this strategic water resources analysis. And what I'm going to present today is, as you can imagine, the whole process, such a long time, there is a vast amount of results that could be presented, but I'm focusing a bit on some other topics which are actually, when we look back, which are really important and as important as the results are. So you will see a mix of lesson learned during the whole process and what is the output of the process itself. So let me start. What is the SWRA? And the background is just to make you familiar with the idea of these water assessment. The Nile water is shared by 11 countries. But like everywhere in the world, the stress factors that impact on water availability, water security, it's just the same as it is everywhere. We can say it's population growth. We see an increase of demand. We have water infrastructure development, and that is somehow a crucial aspect. We have climate change, and that will really make a big change in the future. And we can see that already in recent years. So that is the contribution of all is a real challenge in terms of how to manage water. What can we learn from the past? What will be the future? What will be the likely future? And what we can say about water availability in spatial and temporal resolution. So this discussion is ongoing since a long time in the Nile Basin. And in 2015, the Nile Basin Initiative initiated, we call it a collaborative water resources assessment, and that was instructed by NILECOM. NILECOM is the highest, the largest, and on top committee which is steering the whole Nile Basin Initiative program and progress. So that was the, let's say, the starting point. And from here, the question was, what will happen in the future? And so the objective was here to develop projections of water demands in the Nile Basin. That was one topic. The next one was, when we have this, what does that mean in terms of future water availability? And if we have this, then we can conclude, is it likely that we get water deficits? And when we have water deficits, or in other words, a supply gap in space and time, then what kind of countermeasures are available? In this case, we call them strategic options to balance water supply and demand. And to what extent is that possible, and what needs to be done? Which options are generally available? What is their contribution, their potential contribution? And of course, what is the final conclusion? Do we have to change something? Is cooperation maybe one option? All this should be, or was part of the entire assessment. So when we talk about objectives, and this is now also this parallel process that was ongoing during the entire process, we have also challenges. And that is typically, when you look at the Nile Basin is huge, and it's definitely not homogeneous in the sense of what we can get, what the countries are, the thinking and culture in the countries. And that is also reflected in the hydrology. The hydrology is completely distinct from, let's say, from the north going to the, from the south going to the north. And that means we have challenges, and these challenges impact somehow on the process. And let me just quickly tell you some of the challenges. Data acquisition and data format harmonization. That was from the very beginning something which you have to tackle, you have to address, because it's a vast amount of data acquisition was necessary. But this needs to be transformed in something that is digestible later on for the assessment. So here, it's definitely the question how to harmonize that and how to make it, let's say, transparent from A to Z, from the point where the data was acquired until you transfer the data into some, call it parameters, so that a model or an approach can use this information. Another challenge is the project life cycle was quite long. Now, what to do with the data when you have a process which lasts for a couple of years, and in that period, data updates will come up. what to do with data updates when you are in the middle of the project. Do you go back to square one, for example, and you redo some of the simulations, you redo some of the assessments? So coordination with various stakeholders, as you will see, and that goes together with the next point, contributing building blocks. This is a real challenge, and that is not easy to solve. As you will see later on, coordination is one of the big points here when you tackle such a big project with the entire Nile Basin and so many stakeholders involved and different sectors involved. And then, of course, set up an appropriate modeling environment. And some of the objectives or some of the better prerequisites, they get clear while you are in the process. So at the beginning, you make a guess what is probably needed, but later on, you will really see that at some point, something comes up which was not envisaged before. So you have to change something, or you have to look into some new modeling options and keep that updated. And finally, how to present results so that are easy to understand. You will later see what the major problem here is. So, and of course, as I said, countries and the countries' expectations are not homogeneous. So you have to meet the expectations from the countries as well, which are diverse. So it's not harmonized among the countries, of course. So the process in itself, this is the whole timeline. Started 2015 and it finished in 2023. And it was basically a two phases process. Phase one was about the data acquisition and to get all the basics together in terms of hydrology. That means climate input, water use, collect country plans. That goes into the direction of water infrastructure development. And of course, climate data acquisition. Hydrology here means we need soil information to conduct the respective calculations in terms of soil moisture, irrigation, and so on. And we need land use, for example. That was done. And here also the baseline was prepared in terms of a modeling environment and to bring all together so that we see it's complete, it's complete, and we can move to scenario development. That is more or less on the side of phase two, sector studies, which we call then in the process building blocks. Each block represents a sector and contributed in various ways. Then developing the modeling parameter from here to there, you interpret what you get here, what you collect here, you have to interpret in the terms of making it utilizable for a model. And then, of course, scenario development, because we look into the future. So we can't say that is true, that is real what we do, but scenario development is about what could be a likely development. And we want to see when we make worst and best case scenarios where we are. So we have two phases. And now the building blocks tell us something about what is input from different sectors. And as you can see here, all these green rectangles, each rectangle represents a building block. Let's start with M and I. M here means municipal and industrial water demand. So that's what is needed, and that is a demand building block, as well as irrigation is also a demand building block. And here country plans went in, which says we have a current situation in terms of irrigation, but we will have a future situation as well, because countries have plans. The plans differ in terms of how concrete are the plans. We have some very concrete irrigation plans, but that goes up to, let's say, kind of a vision in the far future, what could be developed, what could go under irrigation. Navigation is a demand in terms of flow and water level at particular river reaches, so that you can interpret as well as a demand, but in a different sense. It's not water consumption, but it's maybe it needs some kind of operation and adjustment. Desalination, that is one option in order to counter a potential supply gap. Where is it possible? To what extent is it possible? And then let me quickly go through that. E-flow is, you can call that as a requirement to keep nature going, in other words. That means at certain location, you look when a certain development will happen. How far do we divert from what is called a natural flow regime? And when we say a natural flow regime, we automatically assume that is a healthy flow regime. And it will degrade to some extent if the E-flows are not met. So that is a contribution, but does not tell anything about the demand in the sense of water consumption. Water reuse is the same as desalination. That contributes in the sense of an option. When we do that, how much can we save? Wetlands and E-flow go somehow together, because in the wetland study that was conducted, the objectives to sustain and preserve wetlands was mentioned, and some matrix was developed so that we could see, is it possible and to what extent the wetlands will degrade? And then coordinated operation is something which actually impacts on the way dams are operated. To what extent can coordinated operation help in terms of water savings? And you will later see, is that the major topic, or is coordinated more on other topics? And water savings in terms of coordinated is maybe not that much an issue. So you see the input from the building blocks, because it took already, of course, a couple of time when they were initiated until the results were available, and the results came in the period from here to here. So some were quite fast, and that was able to digest the results for a long time, and others went into the study just at the end of 2022, and that means that's a real challenge. If they come in late, then you really have not much time to incorporate and digest the results if a deadline is clearly set to finish everything. So that is really a time challenge here. Now the data challenge, I will just tell you two examples in terms of the data challenge. We have water users that go into a comprehensive river basin model. We have river and we have reservoirs. So at the basic elements, reservoirs can be interpreted as dams, lake, wetlands. Water users are the municipal, commercial, and industrial water users, and irrigation. So let me tell you something about the data challenge that arose during the entire process, and which is really a challenge because you have to deal with so many information. So the first thing is, when we talk about irrigation, what is needed and what needs to be harmonized? Soil information. Okay, you have a chance to take the FAO information or other data platforms, but that should be somehow validated by information on the ground. But then when it comes to the crops, the crop coefficients and the cropping patterns and the efficiency, that is a huge effort to get this together. And the point is, finally, you have to ensure that what you do in terms of crop water requirements for the entire Nile Basin is based on something that you get a harmonized calculation approach. So you have to make sure that efficiencies are interpreted in the same way in all countries. And that feedbacks to the country experts. And in phase one, that was one of the major efforts that went into the entire SWRA to get all this clear and to collect that in the best possible way so that we have really a harmonized database. And if something goes wrong here, it is easy to understand that this will really make a big difference. Irrigation is the largest water consumer. Now, going back, dams. Another challenge is, of course, what do we do with dams and dam operation? Operation rules were only partly available, and we have more than 80. When we look into the future, these water infrastructure development plans, they foresee to enhance the number of dams to a large extent and in different regions. So at the end, we had more than 80 dams. A simplification is necessary because you can't reflect the real operation, which is ongoing on a day-to-day basis in such a model like this. So in other words, assumption on filling and emptying phases was necessary. Of course, the GERD went into the entire model, and that is quite a real big thing because GERD can impact on the flow regime. And we had to assume in the whole process that GERD is in operation because we did not look into the filling phase. But then the point is, what about the GERD operation rules? In terms of long-term operation, they were not known, and that means we had to use assumptions. Basically, to wrap it up here, assumptions are necessary, and resemble the reality is really difficult. Here you have to ensure that the entire process does not divert too much from reality, but you cannot expect that you really implement 100% operation that is really ongoing on the ground. So some balancing is necessary so that you really get a good running model in terms of the challenges with the operation rules. Now, looking back to progress and updates, the major problem we faced at the end of the project were really updates of data. You can imagine what happens when we start in 2015 to 2023. Data collection finished was around here. Model toolbox development finished around here. Simulations conducted finished around here. So that would mean, fine, we have enough time to digest results, prepare everything. But what then happened is updates of irrigation plans came in, we received that. Why? To some extent, it's logical. If you look at 2015 and until here, there is some ongoing development in the countries. So that is one question, is a time problem. And when we have this time problem, you go somehow back to, you have to redo the simulations run. You have to redo from here to there to bring that information in a proper way into your environment. And that problem caused one thing which was not nice, but it was real, that it was time foreseen to exchange the model, to exchange information with the countries. But that was reduced to a minimum actually because of these, let's say, not of these feedback loops during updates. So that is one thing which I bring on the lesson learned later on, because that is a dangerous point, because when you spend too much time into updates, other things will, let's say, will be reduced and get less attention. So the result dimension problems is quickly told. If you look at, we have more than 200 subbasins, more than 300 water users, more than 80 dams. Every node has a time series result for every scenario. And it looks like this. You have many nodes. At each node, you have a time series. And if you look into the dimension, you get time series and you can have many locations. But what to do that? How can you display the results so that are really easy to understand for those who are not fully familiar and 100% involved in the process, decision makers, for example, and how to display results so that they are comprehensive? That is a real challenge. And that means we try to apply different ways. And I just took one example out of the entire setup, what we produced in terms of results. And what was done here is you can compare different results and scenarios when you aggregate, when you look into some aggregated form of information, when you show that as in a spatial way, a kind of a longitudinal section, and then you see what is the change when you apply a different scenario. Red in this case was the current situation. and blue was a future situations where the assumption was we have a full development of water infrastructure plans, but there is no improvement in water use efficiency, which is somehow a worst case situation. When you look in full development means much more water consumption, but still based on the same water use efficiency. So then you see what will happen at different locations, but that of course is not the whole story, but you need more information. So we looked at water demand and the change of water demand. We looked into hydropower and the change of hydropower and many other ways of displaying results have been set up and have been produced and brought into the report. So in the hope that this is easy to digest, but I know it's not easy to digest. No matter what you do, the area is huge, complexity is high in terms of understanding what really happens at different nodes in terms of the time and spatial resolution what we have. So that is really a challenge, and you have to think a long time about that, how you can display that so that it's easy to digest. A first summary about the challenges. Coordination of all activities is really and was really a challenge. So many building blocks came in and so many data collections, so many stakeholders and expectations have to be fulfilled and have to be met. Harmonization of parameters when you get that information. I explained that when you get the information from different countries, it must go into one, let's say, transparent framework, in one transparent modeling framework. Data uptake challenge due to long project lifetime, and then availability of water infrastructure operation data. And I can imagine that this will last for a long time because that is really a challenge. How do you get and how do you interpret operation, which can be so complex, to bring it down, to break it down into something reasonable and digestible for such a big study? The lesson learned is we need, and that must be clearly from the very beginning, a rigorous plan how to update data during the project. Otherwise, you run into these endless loops, and that brings you more trouble than ever. And we need more time for that simulation, because if the process is really long, you have to take into account that that will happen. But then there should be time enough so that the full involvement of country modelers is still possible. And finally, the last slide, and that is about the results. I wrap up in terms of the results in a very quick way. There's a high confidence that water deficit will occur in the future. And that is the major message. A combination of measures is required to counter the supply gap. And the combination could mean an improvement of water use efficiency is something which should be promoted in any way. Water reuse has a high potential. The identification was from the building block that water reuse can help with, can save up to 60.5 billion cubic meter a year. Water deficit irrigation was one of the building blocks. And when analyzing this, we saw that the potential can come up to 11 billion cubic meter per year. Crop shift was also one result from the building block of irrigation, and identification of the results went into roughly 6 billion cubic meter per year, but that entails a strong transboundary collaboration. Then desalination was almost entirely limited to Egypt. Coordinated reservoir operation, the building block that looked into that concluded that this is absolutely important for dam safety, flood and drought management. But in terms of water savings, the contribution is not that high, actually quite low compared to the other measures. And demand management is something which was not really tackled in one of the building blocks, but is something that should come up and will come up in the future. That is somehow unconditionally necessary. One point, the last point, and then I close my presentation, is Conjunctive use is one of the opportunities for the future. Conjunctive use of surface and groundwater, because that was not fully integrated into this assessment and will be, most likely will be integrated into the future when this strategic water resources assessment will continue. Thank you very much for your contribution, and I go back to the moderator and hand over to him. Thank you very much.
Thank you very much, Prof, for that very interesting presentation. And we are going to have some questions later on, but for now, allow me to go to the next presenter. And I'll call Mr. Olof Jensen. I'll give a bit of bio for Jensen. Mr. Jensen currently holds a position of Vice President for the Global International Development Business Unit at DHI, Danish Hydraulic Institute. Previously, he was the head of the department, head of projects, team leader, and technical expert for more than 20 years. His experience is in leadership, project management, water resource management. He has worked intensively across Africa over the past 20 years, being involved as technical expert and team leader and manager. So his presentation is going to be on the use of decision support systems to assist inclusive water management and foster transboundary collaboration with cases from the Nile Basin, as well as international case studies. Welcome, Mr. Olof, for your presentation.
Thank you, Professor Norbert. I hope you can see my screen and you can also hear my voice.
Yes, we do.
Thank you so much. First of all, I would like to congratulate NBI on hosting this excellent webinar series. It's really great to see all the interesting presentations and all the participants taking part in this. And also thanking NBI for inviting me for this session. This will be a relatively brief and relatively high-level presentation focusing on the role of decision support systems and how they can foster a sustainable water management in a transboundary setting. I will focus on the Nile Basin, but I will also provide examples of how the work we have done in the Nile has actually impacted and been used in international settings. So this is just some of the agenda points that I will go through. I will start in the Nile, and then I will talk a little bit about our experiences from the Nile Basin. I will show a few cases internationally, and then I will provide a few bullet points on the way forward for the NBI, DSS, and DSSs in general in the Nile Basin. Very short on where I'm from. My name is Olof Jensen. I'm heading the Global Water Resource section at DHI. We are a Danish company. We are just around 1,000 employees. We've been around for almost 60 years. We have 59 years this year. We have 60 years birthday next year. We are a not-for-profit organization focusing on water-related issues. We are both doing software development, but also advisory and research. And we've been working with NBI for the last 20 plus years. I just wanted to start with this slide, just to highlight that decision support systems can actually play a very active and role in fostering coordinating and cooperative decisions in a transboundary sessions, because they can actually take form as an agreed technical platform, allowing for coordinated and collaborative decisions on water management, and then actually take the focus away from the underlying technical issues, and then allow the stakeholders and entities to focus on the real issues, and then take decisions that will lead to a sustainable water management in a complicated system as the Nile Basin. I just want to point to the starting point for our work, or one of the starting point for our work in the Nile Basin, which was a project we did, was funded by the World Bank. We did for NBI back in 2009. And the whole aim of that project was to develop a decision support system for the whole Nile Basin. There was, at that time, it was really a project that was on the edge of what was done. And it was also, at that time, NBI was really a front runner with respect to enabling decision support systems in transboundary settings in Africa. And the whole purpose you can say the vision of the NBI decision support system was to have a common platform to being used across the entire basin. So basically being used by the individual countries, the individual ministries, but then at the same time enabling a common understanding and agreement on the hydrology and the water management across the countries. And it also allowed an insight into what is the impact of certain investments in one country, what is the impact on downstream countries or downstream entities. So you have this holistic system or holistic approach to water management. At this time where this was implemented, this was also, you can say, constrained by the technical abilities at that time. So it was quite complicated. It was a desktop application. It was not super user-friendly. But it was a system which allowed to interact with the underlying water resource allocation model covering the entire Nile Basin. It had different managers, as we call, on top, which allowed the users to do in-depth analysis and in-depth evaluations of different types of climatic and hydrological issues. So it was actually a system that fully supported the needs and requirements at that time, but at the same time also a very quite detailed and quite a complicated system that actually required quite a lot of expertise. And when time has moved on, we started with the NBI DSS. We then further developed this into what we call microoperation, which the day-to-day is actually at the back-end part of all our decision support systems. But as time has moved on, we have further developed and enhanced this. So today, a system like this is operated in the cloud. It's much more simplistic than the original NBI DSS, and it's much more focused on being user-centered and not so actually serving the decision makers much more than actually serving the technical experts, which was the case back in 2009 and 2012. So basically, the NBI DSS, which started as an excellent program and an idea and concept back in 2009, has now led to a concept which we have applied regionally in Africa, but also on an international scale. And I'll just very briefly show some examples of that. So today, what we call a DSS is much more than it was back in 2009. Today, it's a cloud and web-enabled service where users can access the DSS from anywhere, from a mobile or from a tablet or from any internet connection. It provides an quickly update of the information and the status of the area. Today, we are linking up to Earth observation data, to real-time data, to sensor data. So it's a much more rapid and much more responsive system than it was in the beginning of the DSS development. Today, we also, this is just some examples of some of the latest interfaces we have developed for NBI. This is from the flow forecasting and drought monitoring system that we developed for NBI. And this is just to show some examples of how the NBI or the DSS has evolved from being very expert-oriented and very requiring a lot of detailed knowledge to today having a much more simplistic and much more user-centered interface. The work that we did for NBI almost 15 years ago, this has today evolved into a DSS, which we have been applying and is being using in international river basin organizations. We are today, this year and next year, we are working for the Mekong River Commission on a project to develop an adaptive basin plan for the 4 Mekong countries, that is Laos, Cambodia, Vietnam, and Thailand. And then we're also looking at China, the upstream part of the Mekong River Basin. So this is a quite complicated transboundary river basin setting with a lot of countries, which has a demand which is developing very fast. And at the same time, you also see severe climate change impacts in these countries. So here we are basically implementing a DSS, which allows the Mekong River Commission to monitor and evaluate the status of the hydrology and the climate across the 4 countries, but also implement and evaluate different investment options and then see what are the impacts of these options across multiple sectors. And the work we're doing here in the Mekong is basically based on the work that was initiated by NBI all the way back in 2009. Another example is the operational decision support system that we currently are doing in Tanzania. It's a World Bank funded project where we're working in 3 river basins in Tanzania. Here we are applying water resource information systems, flood forecasting, early warning system, water use permitting analysis, and also dam operation support across the 3 basins. And this is another example of how a DSS system has evolved over time and being implemented outside of the Nile Basin. The future role of DSSs in the Nile, I see DSS systems as being critical for the future development and future water management in the Nile, especially because it is a very, very complex setting with many different stakeholders and many different issues. So what a DSS system can really do, and what I believe the NBI DSS system is still doing, is that it can provide an agreed platform which stakeholders being used by stakeholders and entities to discuss and agree on solutions enabling a future sustainable water management for the Nile countries. And I still see this as a key tool for the future challenges facing the Nile. So one of the things that we are working on at the moment is, together with NBI, to describe a roadmap for how we can further evolve the NBI DSS. What are the current needs that are not fulfilled by the current NBI DSS, and how are we going to include these needs in a future DSS? One of the key lessons learned, I think, is that it's very important to use all the lesson and knowledge that we have gained by using the NBI DSS for almost 20 years. There's a lot of knowledge and expertise that we need to capture and we need to bring into the next version of the NBI DSS. So just as a summary, when NBI initiated the NBI DSS back in 2008, they were really a front runner, not only in Africa, but I would even say on an international scale. We are working with a lot of international river basin organizations, and this was really top of the line at that time. So this was really amazing. But we also see today in 2023 that the use of DSSs gets increasingly complicated because we have a completely different setting with data flowing in a much faster space. The availability of data is much higher, and there's also a much higher cross-sectoral focus than we had at that time. So the need and requirements for DSSs today are much higher than it was at that time. So as a final remark, then we are in strong support of the NBI DSS, and we are also in strong support of trying to increase and enhance this over the coming years. And we still see that as a key tool for getting stakeholders to agree on solutions for complicated transboundary issues, which we see in NBI, in the Nile Basin, sorry. So I would like to thank you for this, and this is the end of my presentation. Thank you.
Thank you very much, Jensen, for this interesting presentation in the history of DSS, starting from the Nile Basin, the new development, and also for giving a bit of roadmap on the way forward for the Nile Basin. Thank you very much. We'll come back to your presentation later on with some Q&A, but for now, allow me to go to the next presenter. Is Dr. Mohamed Bashir. Mohamed is an assistant professor at the Department of Civil Engineering, Civil and Mineral Engineering at the University of Toronto, Canada. He is also an Alexander von Humboldt Research Fellow at Humboldt University of Berlin, German, and a visiting research fellow at the University of Manchester, UK. His research is in the engineering and economics of coupled human natural systems, focusing on river basins. Mohammed holds a Bachelor of Science in Civil Engineering from the University of Khartoum, Sudan, a Master of Science in Integrated Water Resource Management from Cologne University of Applied Sciences, German, and a PhD in Water Resources Engineering and Economics from the University of Manchester, UK. Previously, Mohammed worked as a consultant to the World Bank Group, where he assisted in conducting studies on disaster risk management in South Asia. He is currently an external expert for the Joint Research Center for the European Commission, where he provides support on using artificial intelligence in economic planning. Mohammed was a consultant to the Food and Agriculture Organization of the United Nations and is currently a consultant to the International Food Policy Research Institute. Mohammed's core research focuses on designing balanced solutions for complex water resources systems using state-of-the-art river system and economic modeling approaches coupled with artificial intelligence, search, and machine learning techniques. Dr. Mohammed's presentation is going to be on adaptive river system and economic-wide planning framework for the Nile water resources management. Welcome, Dr. Mohammed, for your presentation.
Thank you. Thank you so much. Let me share my screen here. Can you confirm if you can see my slides in full mode?
Yes, visible. Thank you.
All right, excellent. Thank you. Yeah, thank you, first of all, to the organizers for this opportunity to speak at the Nile Basin Development Forum. Today I'm going to present some work that I've done together with colleagues when I was at the University of Manchester. We tried to look at three key aspects. So if you look at this title now, there are three things that I'll be focusing on. So the first keyword is adaptive, and this is something that is becoming increasingly important in managing water resources systems, and this is basically to be able to tackle future uncertainty. So if we don't know much about how the future is going to unfold, we need to be adaptive and have approaches that can adapt to these uncertainties as they happen. Then the other one is river system, and here we developed a water resources system that captures the water supplies, demands, and infrastructure in the Nile Basin. And then economy-wide models, we developed national scale economy-wide models for 3 of the Nile Basin countries, and then we connected all these together in one modeling system such that the economy component and the river system component talk to each other during simulations. So basically, this is the slide summarizes the overall approach that we followed, which includes 3 steps. The first one is simulate, and that includes developing river system and economy models. The second one is called search, and in that step we connect the simulation model to artificial intelligence algorithms to be able to search for the best ways to manage the river system and to optimize the way the system is managed. And then the third step is to engage with stakeholders to perform capacity building and to get feedback from them in terms of how the model is representing the system and how it can be improved. Each of these steps, there are different inputs to them. For the economy, for example, we use the economy-wide models. These are called computer general equilibrium models. We've got climate change projections, hydrological models as well to convert these climate change projections into river flows and so on. If we look at the first component, I'm going to focus on the simulation and the search components in the interest of time today, but happy to take questions as well later on the third component. So in the first component, this is the simulation framework that we followed. So at the heart of it, we've got these 2 yellow triangles here. We've got an economy system model that can simulate the economy-wide performance of a country's economy. So such kind of model captures different economic actors and sectors and can simulate economic growth, and then also the demand for resources for different economies. Then we connect that with the river system infrastructure model, and these are the models that previous presenters showed similar to them. So you can simulate things like irrigation water supply, irrigation water deficits, hydropower, etc. What we added in addition in the framework is the ability for the two modeling systems to talk to each other and communicate at the model simulation time step, so that they are homogeneous and then they move together forward. Then we've got climate change data that drives both modeling systems. So we've got the different climate change projections coming from the CMIP6 simulations, and here we're using 29 climate change projections. We take the socioeconomic data and we feed them into the economy system model, but also we take the biophysical data and put them into hydrological model and turn them into river flows and changes in evapotranspiration into the river system. And so on, so that all models are homogeneous when they run different scenarios. So if we want to again unpack that a little bit more, the river system infrastructure model, this is a schematic of it. It represents the system to a great level of detail. So it's driven by 29 climate change projections that span from 2017 to 2100. Overall, the model includes 210 nodes and covers the entire Nile Basin, and these nodes include the major water demand, dams, and infrastructure in the system. Then if we come to the economic model, so here we focus on 3 countries, and this could be done to any of the other Nile Basin countries. The reason we focused on these is because we wanted to address a case study related to these 3 countries, the Grand Ethiopian Renaissance Dam. So we had an economy model, computable general equilibrium model for Egypt, one for Sudan, and one for Ethiopia. And then we've got the river system infrastructure model, which we developed using a tool called PyWR, Python Water Resources, which is an open source tool for simulating resource system networks. The CGE models or the economy models for each of the countries, we used a standard open source model as well called the International Food Policy Research Institute economy model. And basically, then to connect everything together in one simulation framework, we used, again, another open source Python framework called PinSim. And what PinSim allows you to do is to manage that time stepping of models together and the exchange of information at model runtime step, so that everything is homogeneous and runs together. Okay, so that's a simulation step. We draw the infrastructure system model, we've got the economy models, we link them together. But then, okay, what do we want to do? We try, the idea is to build a model and try to come up with some management plans. And the way we do that is to search all the solution space, and to try to come up with management plans that are within this red point. So if we imagine that we've got country A and country B, and this is just hypothetical, just to explain the idea, and the objective here is to minimize these objectives. So we could think about these like water deficits, for example. Country A wants to minimize water deficits and country B wants to minimize water deficits. So both of them, they want to be at this point here, but that's not possible because in the real world you have trade-offs. But then again, you've got all these here dark points here that are dominated, we call them in optimization terms. What we want to do is to find these red points here, and these are called non-dominated solutions. Economists call these points Pareto optimal solutions. So the idea from the search process is that it goes through the solution space, and then it comes up with these solutions here. And then what we aim to do is to provide these solutions to decision makers to make a decision in the end. So what we try to avoid is these solutions that don't make sense to even look at. You want to be able to discuss and negotiate and deliberate based on these non-dominated points. But then how do we do that search process? Okay, that's where artificial intelligence comes into play. There is something called multi-objective evolutionary algorithms. And these are algorithms that try to imitate the natural biological mutation process, whereby you connect the simulation model, which we talked about earlier, the economy and the hydrology together and the infrastructure. And then we've got the evolutionary algorithm on this side. And what happens is that both of them, they iterate over thousands and thousands of times until they figure out where these red points are. And the idea is with every solution, you've got some objectives that you calculate using the simulation model. You go back to the evolutionary algorithm, which then tries and modifies the management practices based on what it learned from the previous solution, and then suggests a new solution. And then with time, it moves towards that right points. Okay, so that's the framework. Let me talk a little bit about what we applied it here for, and then I'll close my presentation. So we've got the Grand Ethiopian Renaissance Dam, which is being constructed here, has a storage capacity overall of around 1.5 times the mean annual flow of the river at the dam location. Hydropower capacity of 5,100 megawatts, and is expected to double the overall electricity generation in Ethiopia, which is great and will improve the economic performance in the country and will definitely stimulate economic growth. But then there were some concerns by the downstream countries, Sudan and Egypt, and the idea was, okay, if we bring in climate change and we try to come up with some way, some adaptive way to manage the dam, yeah, and then compare it to some scenario that has been discussed by the countries, we want to see whether we can actually have some benefits from that. So what we did is we started from the technical proposal that was published as part of the Washington discussions. And the reason we use this one, because this is the only publicly available proposal, technical proposal, a detailed proposal that's out there. Everything else is not publicly available. So we started from there. We simulated the system under climate change, and then we connected the simulation, the whole planning framework to AI, and we tried to come up with an adaptive strategy under climate change and with increased level of cooperation, and try to see whether that's actually, makes sense. The way to do that is instead of having one fixed plan over time, is to have some short-term plans and then to have an adaptation mechanism over time that allows adapting as new information becomes available about climate change and how river flows are changing. That way you don't have one fixed plan, but every 5 years, what we do is every 5 years, we look at how the flow changed as a result of climate change and then adapt our the management strategies accordingly. So this is just an example of the results that came out of the framework. This is called the parallel coordinates plot. So basically what you do with the parallel coordinates plot, you've got multiple axes that are aligned vertically, and each axis represent one metric. So here we look at, for example, the GDP of Ethiopia, the change compared to the Washington proposal here, GDP of Sudan, and so on. So here, this is, first of all, what's interesting here, this is the mix between economic metrics and engineering metrics. So you've got hydropower, water supply, and so on. But then at the same time, you can see the black line here, this is 0. This represents the line where the Washington proposal is. So everything else is just deviations from that line. So for example, if we've got a solution that's favorable to Ethiopia, here we pick the one that has the highest increase in GDP to Ethiopia. And that results in very low one of the lowest performance for Egypt. If we pick a line that's high performance for Sudan, then we've got low for Egypt and a little bit lower for Ethiopia. So there's a trade-off that needs to be recognized. And then the countries, if they could agree on something, a compromise that sort of balances the performance across all of them, and that would be the goal in the end. I mean, this compromise, we picked it ourselves as academics, but hopefully the idea is for the countries to look at these solutions and to pick one of them. So to conclude here, what we try to figure out at a high level from this study, first of all, is that climate change is important and should be considered in the negotiations. It shouldn't be, proposals cannot just be developed based on historical hydrologies. looking forward and trying to be adaptive in our thinking and in our negotiations is important. Second, we found that also using multidisciplinary metrics is quite important because it helps communicate the complexity of these results. If you can summarize things in terms of how GDP is going to change, or how employment is going to change, or which household groups are going to benefit, that's normally easily understandable by decision makers. Then in the end, again, this is something that we didn't mention before, or I didn't mention in the presentation, but this has been done in communication with stakeholders from the bottom up, and that's important for them to understand how the model works, and then to be able to adopt the results. If you want further information, you can have a look at the paper here, and thank you very much for your attention.
Thank you very much, Dr. Mohammed, for that interesting presentation and for taking us to the emerging technologies, AI and machine learning. Thank you very much. We'll have some questions later, but for now, I think I'll go to Dr. Manuel Arasa. Dr. Emmanuel, are you online?
I think he has internet challenges, but
Okay. He's trying to join, eh?
He's trying to
also, okay, but also I want to ask Mr. Gashau and Lalu to log in using the link sent to his email. Mr. Gashau, please use the link which was sent to your email to log in.
Maybe Professor Joel, maybe
Yes.
you can go with the Q&A until maybe one of the other panelists can join also.
Okay, thank you very much, Dr. Mudadir, for that suggestions. Yeah, then I think we can go for Q&A, and I'm going to start with the questions which are posted online here. Okay, the first one goes to Professor Hubert. It says, on desalination, is there a limitation on the amount of water to be desalinated? What are the general factors which restrain the use, I think, of desalination?
Yeah, thank you. Very good question. Very interesting. And I also learned a lot when I got the report on desalination. And the limitation is actually the distance to the sea, to the shore, and the costs in general. The distance to the let's say you need a point where you abstract water from the sea, and then you have a target location. And that distance is somehow limited with round about 160 kilometers. That is on current condition. That's the maximum distance, which gives you still an economically viable output. If you go further than 160 kilometers, that is an output from the building block, then you never can compensate your costs. So it will be a loss in terms of the economic value of that desalination. So the building block of desalination determined a maximum distance of 160 kilometers. And when you look at the Nile Basin, and then you need a shore, a point at the sea, and then you can draw 160 kilometers from that point. That's the area which is on current condition, which is suitable in theory for desalination. And that is roundabout, you can say, Egypt. And another point was mentioned in the building block costs. Desalination is high energy. You need a lot of energy to do that. And that means a lot of money goes into desalination. In other words, it's really expensive. And these two factors were determined in the building block and were the restriction in terms of using desalination.
Okay, thank you very much, Prof. I think that is nice. And then the other question is on the GERD. I think is probably addressed to Dr. Mohammed. Is saying the GERD operation, how is the GERD operation is going to change the operation of other downstream dams? This need to be considered. I think is a comment. Probably Dr. Mohammed, maybe you can say something on that, whether this is how is the GERD dam going to affect the operation of the other dams downstream?
I think this question was, or this comment was addressed to Professor Hubert.
Okay, Robert as well. Oh, sorry.
Okay, so I can give a response. Yes, absolutely true. It will change the operation of downstream dams, definitely. And that was investigated in the building block of coordinated reservoir operation. And there we try to find rules which are adaptive to the new, let's say, to the new flow regime coming from the GERD. So that was done in the building block. And in the SWRA big study, the operation was changed, but in a simplification. That means in a simplified way. In the coordinated reservoir operation building block, which was specifically dedicated to reservoir operation, in that building block, it was really chapter and detailed investigation, how the operation should be changed, what is the benefit, where are limitations. But in the big SWRA assessment, this was then simplified because we lack some detailed information in the SWRA, and the big scenario was not able to cope with this fine-grained operation at this part. But it went into the assessment with a simplification. And absolutely true, there will be a change, and that needs to be considered and taken into account, which was done, but in a simplified way in the SWRA.
Thank you very much, Prof. And the other one maybe probably is also related to you, but I think is more to Jensen. It says a lot of effort was exerted. I mean, a lot of effort was exerted, a lot of money was spent in the Nile Basin DSS. However, the results are minimal. The practical application of the Nile Basin DSS has to be reviewed. I think it's more than a comment. I think maybe Jensen, if you can comment on that, and then also if you have any comment.
I'm very much in agreement with that comment, and that's also why we need to look at what are the current needs for DSS in the Nile Basin, and then really react to that when we move forward. I think there's a lot of reasons why it was difficult to use the original NBI DSS. One of them was availability, was built on a time where everything was used on a desktop computer. There was a dongle, so the accessibility of the system was limited to the focal points for the DSS, and it was difficult for other people to actually access the NBI DSS. That's completely different today, where you have web and cloud interfaces, and you can access them from anywhere as long as you have an internet connection. So the times today is just completely different. And then there's also the complexity. It was built at a time where there was not a lot of previous examples of DSSs, so the complexity was high. It is a system that can do everything which is needed for a strategic water resource assessment. So it has all the functionalities included, but it requires a lot of expertise to use it. And this is also something we have learned over time, that today a system like this needs to be completely different. So there's a lot of lesson learned, and these are the lessons learned that we need to bring forward into a new process of redefining, reshaping a DSS for the Nile Basin. Thank you.
Thank you very much, Jensen. And maybe I can add one question to Prof. Hubert on the same. So, Prof, what is the main objective of strategic water resources assessment, taking into account the work which has a lot of work which has been done in the Nile Basin using the Nile Basin DSS which was started in 2009 to 2012. And now for phase 2, what is the main objective?
Main objective was to identify the supply gap. First of all, you have a water supply and then you have a demand. And in the future, you will have a gap between what is available in terms of water and the demand is rising. And that problem is apparently there in the Nile Basin in the next years when irrigation will develop. And the strategic water resources assessment tried to find strategic options, which means desalination, water reuse, water use efficiency, a better water use efficiency, and to what amount of water can this contribute to reduce the supply gap, and to see which option at which location is most suitable and which is maybe not that much promising. That was the main objective. And let me say a few words when it comes about the Nile DSS. Actually, we didn't use it because of the reason why it is stated in the chat that for us it was useless. So we went into some other options. We just took the data out of the Nile DSS and then went ahead with a model chain which was more appropriate for solving and doing the assessment.
Okay, thank you very much, Prof. And maybe let me go on to the other questions on the chat. And it goes to Mohammed. Mohammed, thanks for the presentation. How is the future water resource development upstream of GERD? How is it accounted in your model?
Yeah, thank you. Thank you very much for the question. Perhaps there are two things here that I didn't get the chance to mention in the interest of time. So the first one is actually the model that we developed includes all future infrastructure. So in terms of data, everything is there in terms of irrigation and dams. What we did in this study specifically, we made a modeling choice that we want to deactivate all of them. And the reason we did that, and we did not consider them in the analysis, is because we wanted to do a first study where we demonstrate the value of adaptive management under climate change. And the best way to do that is to isolate a single piece of infrastructure, and here's the GERD, something that everybody's familiar with, and try to look at the magnitude of benefits and the order of benefits that the countries can get from adaptive operation of just that one single dam. We've got a couple of other studies that are underway and will be coming out soon, looking at not only how to operate dams, but also how to expand, how to build other dams in the upstream, considering the evolution of climate change. When is the best time to build a dam in the upstream in a way that doesn't result in negative impacts on the downstream? How can the downstream help also build the upstream dams by for example, using their storage during the construction and filling phases? These are studies that are coming up, but the answer to your question is that was a modeling choice, just to be able to demonstrate the benefit of adaptive management.
Thank you very much, Dr. Mohammed. Maybe another question also goes again to Prof. Hubert. Do you believe that the Upper Nile country currently uses irrigation on the Nile River? And what is the impact of this on downstream countries?
Yeah, thank you. A good question. And the data that we got shows that currently there is a minimal use in terms of irrigation upstream countries. The future is different because we got future plans which are, let's say, quite considerable in terms of what they plan in terms of space for irrigation and water consumption for irrigation. So that was quite a difference between current and future outlook. And when we look into the scenarios, that has, of course, an impact and contributes downstream to an increase of the supply gap, but the proportion was lower compared to the future plans that came from, for example, from Ethiopia, because that was much more closely related. Ethiopia, when they do something, it has a direct impact on Sudan and downstream. When the upstream Nile countries do something, there is still the soot in between, which is a dampening factor, so that you don't see exactly a one transfer of upstream abstraction downstream to the Egypt and Sudan locations. But there is, of course, an impact if they will reduce the water, but that impact will go on the soot more than on a downstream part. The soot will suffer more or less a bit more when you abstract more water for irrigation upstream. But currently, the question was about current. There was is minimal use according to the data from the countries.
Thank you, Prof. Maybe I can also add one question there. Looking at the challenges of data in terms of, you mentioned the challenges of data in terms of, for example, irrigation efficiency, the issues of dam operation, and the issue of harmonization. What confidence can you put in your results in terms of what you are saying now?
In terms of, it's also a good question. The confidence in terms of irrigation in phase 1, what happened there is when all the data were collected, then irrigation models were set up. And when they run, and crop water requirements was a result, of course, and then the results were discussed with the country, whether or not they can confirm the demands. That was the first phase of validation. And from that phase 1, we concluded that validation was sufficient. So the confidence in terms of crop water requirement is okay. It's not perfect, definitely not, but it was okay. So it was reasonable because that was the highest, or that is the highest water consumer. But that was all dedicated in phase 1, this validation part with irrigation. That was a lot of effort. We were not involved those days. We came in phase 2. But when we discussed that with the team who did phase 1, they said that was really the big bulk of workload, what they did in phase 1.
Okay, thank you very much, Prof. And maybe now welcome, I guess it's Professor Mohamed Yassin, or is Mohamed Yassin, can you ask your question straight away? Mohamed, are you online?
Yes, I am online. Thank you. Good morning to all of you. You confirm that you are hearing me?
Yes, yes, we can hear you.
Oh, thank you very much. Thank you for this interesting presentations. My questions goes directly. It is a curiosity. Now using this artificial intelligence and sensitive remote sensing technologies in measuring the and also after the constructions of the new dams, especially Marawi Dam, do you think why the I have a doubt that the quantity of water is 84. 84. This narrative of 84 constant. I don't believe that it is constant. So when Dr. Muhammad Bashir says that there is variation and there are trade-offs, and the academicians are convinced in it, but the decision makers should find a compromise. If the data, the historical data, prove to be not accurate, that means this quantity of the water is not a constant figure. So will there be a room to revise this and maybe find a win-win solution between the stakeholders who are engaged in the Nile Basin, and how we are going also to use this for future, for the constructions of future dams, especially the 4 dams which are supposed to be erected in South Sudan. Thank you very much.
Thank you very much, Mohamed, for that question. And yeah, maybe I can ask Mohamed if he can comment on that, or Hubat. Mohamed, please.
Yeah, I can say something. I mean, we did climate change simulations for river flows until 2100, and certainly what you can see is there is high uncertainty regarding how climate change is going to affect the Nile flows. So you get some scenarios from certain model simulations that show a decline of something like 20% in the flow. You get other scenarios, and they're with different models that show an increase of 90% in the flow. And that depends on how climate change unfolds, how we behave as humans in terms of sustainability and the use of fossil fuels and so on at a global level, not just in the Nile Basin. So my take on this is that climate change is definitely changing the flow. So I think the historical average flows or even flow patterns, flow variability, this is going to change or have already been changing. And yeah, and I agree that the flows that we knew historically are not the flows that are happening now anymore.
Thank you very much. So that's the policy issue. That means how do we incorporate for decision making and the policy issues? Thank you very much, Mohammed. Is there anybody else who want to comment on that? And if no, I'll go to the Hubert, please.
There's one question which I find really good. That is about green energy. There's one point with following up. Do you think potential green energy in the Nile Basin countries can chip in to provide energy to desalination? That is a great point, I think, and that is also an excellent outlook. And yes, I believe that this can really mark a change in the future, because I know from an international viewpoint that green energy is more and more an objective. The desire to go into green energy is increasing worldwide. That means countries in the Nile Basin, they have the potential, definitely they have the potential to use green energy, and that could really mark a big, big difference for the future. But what I know also is it requires an absolutely stable political conditions, because it means green energy, to make use of it, requires a lot of investment at the beginning to make a start. And in order to make that happen, investment at the beginning requires that the countries can provide some enabling environment for those who want to invest. But in the long run, I can imagine that this is really a tipping point, a positive change in the future. Therefore, I think that is really worth considering in the future, this green energy topic. So thank you very much for this question, because that will go into some extent in future assessments, I guess.
Thank you very much, Prof.
He's raising his hand, Professor Joel.
Sorry?
There is one of the participants. He's raising his hand.
Oh, sorry. Let me check the screen. Okay, just a minute.
Can we allow him in?
Yes, please. Go ahead, please.
Okay. Yeah, he's now there.
Okay, Akilu, please go ahead. Hello, Alemayu, can you hear us?
You are muted, Alemayu. Alemayu, you are muted. Okay, I think Professor Joel, maybe you can continue.
Yeah, let me continue. Then probably maybe forgot to put down his hand. I think he is also asking Dr. Mohammed, what is the best management way you recommend for those 3 countries?
That's more like the $1 million question. I definitely cannot put my hand on one solution, but I think overall it's important to recognize the need for adaptive management and for considering climate change. what we can do is, point out these red points that I showed in my presentation, which still includes trade-offs. No matter whether you're adaptive or not, there are trade-offs in the Nile Basin, and it's important that negotiations and discussion happen based on these Pareto optimal solutions, considering the best set of trade-offs possible.
Okay, thank you very much. Maybe I had one question on that again. What are the main findings or efficient options identified for the case of the adaptive planning framework when designing an adaptive management policy for the Gear Dam, taking into account the interests of Ethiopia, Sudan, and Egypt in the specified time?
Yeah, so that's a good question. So what we did was to come up with a certain set of rules, yeah, and that these rules, we look at them every 5 years, and then we change them depending on how the flow changes. So for example, we have a rule where, if there are deficits, if the GERD water level goes very low, then water releases downstream are reduced so that the water level of the GERD can recover. But then if you have an increase in inflow due to climate change, you don't need to keep that rule anymore, because the storage is going to be high anyway. So every 5 years, we look at how climate change affected the flow in the previous 5 years, and then adapt this kind of levels. So we've got other rules that also try to protect downstream countries. You've got other rules that try to protect the GERD water level, and then you adapt all of these on a 5-year interval based on the flow.
Okay, thank you very much. So I think maybe let me go to another question, and yeah, it's not really a question. A question again to Prof. Hubert. Some of the countries submit very ambitious future plans for irrigation. The future plans should be based on studied project, provided a technical and economic viability. I think is more of a comment, I think.
Yes,
Prof.
I can also comment on the comment.
All right.
Because yes, indeed, this comment is true, and that triggered, I can remember that this triggered discussions among the countries themselves when these data updates came in rather late, and to some extent they were quite ambitious. And the question instantly came, is that really feasible? Is that just a vision? Is it really good to incorporate that into the assessment? As a consultant, I have to say, I'm not in the position to question these things when a country when the country gives an update of their plans. I'm not in a position to say, no, this is not what we want to do. Absolutely. I have to put this question to the group of the countries. They need to discuss whether or not this needs to be considered, in what way. A recommendation could be, and actually this is what we then tried, and we did actually, we distinguished in scenarios something which is just a vision and which is based on what the command is, based on studied projects. Therefore, we had 2 scenarios, one based on studied projects, and one, we call them ambitious planned or envisaged plans. So that was the way we dealt with this controversy among the countries. But that's the only way. From a consultant viewpoint, I think that is absolutely okay to show the results when we go this way, when we go another way. And then to show clearly, okay, we have concrete future plans, and we have just a vision of future irrigation sites or whatever. I think that is legitimate to do it like this.
Okay, thank you very much, Prof. And maybe I have one question to Jason Oluf. And Jason, you have explained how the Nile Basin DSS has evolved over time, starting from the hard key, and then now we are talking of the cloud or web-based system. Can you what kind of lessons have been learned from its implementation in various international transboundary river basins?
I think one of the key lessons is around sustainability and the ability for such a system to be maintained and be actually provide value over a long time in a certain river basin. I mean, we can also see there are certain comments around the NBI DSS where there are different opinions on the use of it today, and that's very much. I mean, that has very much been our focus to increase the focus on capacity building, training, accessibility to the system, also simplify the way that complicated indicators, complicated model results are disseminated to stakeholders and decision makers, and also have the ability to disseminate information in different ways depending on who is receiving the information. Is it a high-level decision maker? Is it a technical expert? Or is it an external stakeholder? So you can actually compile the information so it provides value and is useful for the one who receives it. I think being much more agile, being much more flexible, that's the key word here. And that has evolved enormously over the last 10, 15 years, I would say.
Thank you very much, Jason. Yeah, and okay, so that is very interesting. That means in terms of user-friendly and then in terms of easy accessibility. I think that's really very interesting thing. And I want to check again, Gashau, if he is online.
He's not, sorry.
I think he's online, but I think he has logged in a different forum. He's saying he's online, but maybe Dr. Mudadiri can help. I don't know how you can help him.
Okay, we are promoting him from a participant to a panelist.
Yes, please do so. He's online, but he's in the participant group, I think. And
maybe you need to log off and join again. Okay,
Yep.
he come. Okay. He's now
Hello?
here.
Hello?
Yes.
Yes, Gashau, you are now online. Okay, thank you very much.
Thank you. I'm facing difficulties, yeah.
Sorry for that. So maybe you can do your presentation, but now let me just briefly introduce you.
Okay.
We had Mr. Gashau is Dr. Gashau is a PhD. Mr. is a PhD candidate at the Department of Political Science and International Relations at Addis Ababa University. He has published articles on Nile hydropolitics and the geopolitics of the Horn. His research interests include transboundary water resources and governance, renewable energy transition, climate change, and the role of science in policy making. This presentation is going to be on a rising hydropower state. Mr. Gashau, the floor is yours. Can you do your presentation, please?
Okay, thank you very much, Professor. I think I'm going to present another paper, not the Ethiopia rising hydropower state. I think there is, this communication. My title is Powering the Nile Region through the Water, Energy, Food, Nexus approach to the hydropower development of the Nile region.
Thank you very much. Please go ahead.
Okay, thank you. As you see from the slide, I'm going to present the paper on the Powering the Nile region through the Water, Energy, Food, Nexus approach to the hydropower development, patterns, impediments, and policy implications. To begin with, as you know, the Nile River has the potential to generate a significant amount of hydropower. But current approach to the hydropower development in the region has faced challenges as a result of the traditional siloed approach that gives priority to the energy security, to the development of or attaining energy security at the expense of other sectors, such as food, security, climate or environmental security, including also other co-riparians. So this is, from my point of view, hindering the progress towards the achieving sustainable development goals, as well as building a climate resilient region. So my study argues that an integrated approach, the water, energy, food, environmental nexus, is necessary for the Nile region's development, sustainability, and cooperations. So before I provide you the major challenges facing the Nile region from the siloed approach, from the traditional approach of hydropower development, I wanted to give you an overview with regarding the importance of Nile region to the environmental security, energy security, water security, and food security. With regarding to Nile energy security, Nile has untapped hydropower potential, which is nearly 20 gigawatt. But it is not yet exploited. Nearly just 76% of the potential capacity is exploited, mainly in Egypt. And there is also an attempt in Ethiopia and also Sudan and also in the equatorial regions. Again, electricity consumption is also amongst the lowest in the Nile regions, except Egypt, which has more than 90% achieved more than 90% of electrifications in Egypt. Again, some countries in the Nile region are hydro dependent. Take, for instance, Ethiopia, Democratic Republic of Congo, Burundi, and Uganda. This Nile has also nearly 4 to 6 million hectares. But food security is the challenge of Nile basin countries. Look, for instance, the poverty index and so on. Even data shows that more than 40% of the Nile River basin populations live in extreme poverty. Even the majority of the countries are food buyers. Even they are facing problems amidst the Ukraine war. Coming to the water security, water demand also increased significantly as a result of the urbanizations, industrializations, and so on. Coming to environmental security, again, Nile is also home to unique biodiversity that needs to be protected. But the siloed approach or the traditional approach of hydropower development or water resource management is also increasing vulnerability to environmental insecurities. When it comes to the current approach to hydropower development in the region, it is a siloed approach or a traditional approach. That means it is a one-sided approach that prioritizes energy security over other sectors, such as the food security, water security, and environmental security. But if you see the water resource management policy of the Nile countries, they have an integrated water resource management policy. But in practice, it is not, or it is a traditional approach. Again, if you see, for instance, the power trade, there is no multilateral power trade in the Nile region. Even they have no regional power pool. Rather, power trade is bilateral. For instance, there is a power trade between Ethiopia and Djibouti, Ethiopia and Kenya, Ethiopia and Sudan, but it is a bilateral. It is not a multilateral. So Nile lacks also a common power pool or a multilateral power trade. Again, hydropower development in the Nile region is unilateral development. It is not a multilateral. There is no joint project. But recently, there is an attempt for this in the Eastern Equatorial Nile, while a proposal for the joint hydropower development in the Eastern Nile region has been failed so far. The unilateral development, for instance, the Hayas-1 Dam, the Grand Tipian Resus Dam, and others ongoing and planned dams. When it comes to the major impediment to the hydropower development in the Nile region, one, there is a structural defect. This structural defect is largely emanates from the lack of institutions and a legal framework to the Nile regions. There is an attempt through the Nile Basin Initiative and through the Cooperative Framework Agreement, but the Nile Basin Initiative is not yet transitioned to the Nile Basin organizations. Again, CFA is not yet became a legal law due to the delayed ratifications and so on. There is also state fragility, which also affects the development of hydropower and other water resources in the Nile region. There is also colonial legacies. Again, Nile geopolitics is also affecting the development of water resource development in the Nile regions, which is a divisive element. There is also absence of external finance, largely due to the unilateral development approach, the absence of legal institutional framework, and so on. There is also absence of power trade arrangements. The power trade arrangements are bilateral. There is no multilateral. There is not also institutions. There is a Eastern African power pool, but it is not effective. There is also hydro tension. There is also climate crisis. There is high vulnerability of hydro to the climate crisis, such as drought and so on. For instance, Ethiopia energy security is highly affected by this climate crisis because Ethiopia is a hydro-dependent state. The effect of climate change is also visible on water demand in different sectors, in agriculture, in the industry sector, the household, and so on. So there is also a problem of sustainability, largely which emanates from the traditional approach, the siloed approach, that never take into account the trade-off between the four sectors, the energy sector, water sector, food sector, and environmental sectors. So coming to the solutions, I think there is a need of integrated development. Taking water, energy, food, environmental nexus approach is important to ensure sustainability in the Nile region, to ensure the achievement of sustainable development goals in the Nile regions. And the water, energy, food, environmental nexus approach is, I think, necessary for holistic and integrated approach to the hydropower development in the regions. There is equal prioritizations in this approach. There is an equal weighting of the energy, water, food, environmental sectors, which can ensure security across sectors. We can recognize the trade-off. We can also recognize the synergy among the sectors. There will be also collaboration and trend. If we transit from the silo traditional approach of water resource development in the hydropower sector to the water, energy, food, environmental nexus approach, which can bring an interdependent grid community that prioritize hydro cooperations and trade. But this requires, again, an institutional and legal framework. So finally, I think the three things should be prioritized. One is regional cooperations. The riparian countries should prioritize regional cooperations and collaborations to develop the water, energy, food, and environmental nexus approach that is mutually beneficial for all nations. If you take, for instance, within the state, if we adopt the water, energy, food nexus approach, then we can ensure cross-sectoral security within the state. And if we approach or adopt the water, energy, food, environmental nexus approach at the Nile regions, then we can attain cross-border energy, water, food, environmental security. So there is a need to promote regional cooperations and regional collaborations. Again, in terms of investment and planning, there should be a cross-border coordinated infrastructure planning and construction guided by a holistic and integrated water, energy, food, and environmental nexus approach to sustainable development and so on. Finally, there is a need of capacity building at all levels of governance, including in the areas of training, education, is also very important to ensure and to implement the water, energy, food nexus approach so as to ensure sustainable development in the Nile regions. Thank you very much.
Thank you very much, Mr. Gashau, for the presentation. Dr. Mudadir, just to check again if Dr. Emmanuel, if he has managed to log in.
Emmanuel has failed to join.
Okay. And Moges?
Also, he's not there.
Moges is not also there. Okay. Then we can continue, I think, with the Q&A. Okay, if I may go back again to Q&A, and this is addressed to Oluf. The Nile Basin DSS version 2016 and the latest at NBI has been upgraded at DHI. Okay, this is a question. Is there any updates from DHI? And what about training for the Nile Basin nations, or that means refreshing their knowledge? Oluf, if you can comment on that.
Yeah, I don't have a lot to say. I mean, I think it's a very valid question, a very good question also, because technology and capacity building needs to go hand in hand. We have had we have had projects for NBI over the last couple of years where we've also done training, but there's not, to my knowledge, been any basin-wide training on the NBI DSS over the last years. But it's a very, very good question, a very valid question. I don't have more details on this, unfortunately.
Okay, thank you very much, Oluf. And maybe a very small one on the same, Oluf. And in what ways do you envision DSS being further adopted and utilized as an active tool to support sustainable and resilient water resource management in the Nile Basin? And what are the potential benefits of such adoptions?
I mean, I think that the potential benefit is that there is a common platform from which all entities, all countries can use, so that you don't have to spend time discussing on the technical platform, but you have a technical platform which is the common and agreed by all participants, and then you can actually spend the time and the resources focusing on the real issues, which is the hydrology, which is the water use, which is the climate change issues, and how to actually reduce the impact from these important issues. So it is to have a common platform from which actions, plans, investments can be taken from. And then I actually it's not so important if it's a platform developed by this company or another company, but as long as it's a common platform that everybody agrees on, that I see as the key value for a DSS system in a transboundary setting.
Okay, thank you very much, Oluf, on that. Yeah, and if I may go back again to Q&A.
There is a question from Isra, the participant. Can we allow her in?
Yes, please.
Okay. Yes.
Please go ahead.
Isra Salah, you are muted.
Salah, you are muted, I think.
Isra, unmute yourself. Unmute yourself and ask your question, please, Isra. Okay, I think maybe she has challenge to ask her.
Hello, Ezra. Okay, I think maybe it was by mistake, probably. And maybe I have a small question to Gashau. You talked about water, energy, food, and environmental nexus approach. How does that differ from the traditional siloed approach to hydropower development?
Okay, Prof. The water energy nexus approach is totally different from the traditional siloed approach. In the traditional siloed approach, they never recognize the trade-off and synergy among the sectors, the water, energy, food, as well as environmental sectors. For instance, if you take, for instance, water is used for energy production. At the same time, energy production is very important for water supply. Again, energy production is very, very important for attaining food security. Sorry for there is some noise here. I'm in the office. And energy production is very important for attaining food insecurity. Again, food can be also used for energy productions. All this has also an impact for the environment where we are living. So from planning to operations of hydropower projects, we have to take into considerations the synergy as well as the trade-off among the four sectors: the water sector, the energy sector, the food sector, and as well as the environmental sectors. Unless otherwise, we will not attain security of all sectors or security of all water users. If, for instance, if we construct a hydropower project to attain an energy security, regardless of taking into consideration the interest of other water users, maybe the local community or the lower riparian countries, then it will lead to conflict. So the siloed approach or the traditional approach have not bring security of all sectors. Rather, it is also a source of tension, hydro tension, and conflict among sectors within the state, as well as conflict among the riparian countries. Take, for instance, the Nile River countries. There is a conflict. Yeah, this conflict is largely managed from the traditional siloed approach, because they prioritize to attain either water security or energy security at the expense of other sectors, at the expense of other co-riparian countries. So I think there is a need to shift this traditional planning of water resource development into the water, energy, food, as well as environmental security approach. Thank you.
Thank you very much, Gashau. Members, thank you very much for your presentation. I think I don't see any additional question from the, let me just check for the last time. Okay, there is Mohammed Yassin also. He has a question to Gashau. Please go ahead. Yes, Mohammed. Hello, Mohammed.
Yes, yes, because the unmute thing comes in delay. Thank you.
All right, sorry. All right.
No problem. Thank you very much, Mr. Gishau, for the presentation. My curiosity goes to you. You mentioned the structural defects which are the impediments for the hydropower development. But at the same time, I see that NBI and other institutions or other even international development cooperation mechanism are working in order to remove these barriers for the development of hydropower system in the Nile Basin. However, maybe the weight of the politics is high in this. So you are putting the same weight for the same structural defects. So, in your opinion, how we are going to what are the remedies in order to make the NBI more effective in the evolution of the normative, and is there any way that it can push for the CFA to be ratified and be operational? And at the same time, you are accusing the colonial legacies, while the same colonial legacies are those who are helping in pushing for the development and providing the finance. At the same time, how we are going to compromise, how we are going to reconcile with these contradictions and avail the external funding, because I don't think that it will be auto-financed by the riparian countries. So can you elaborate on this, please? Thank you.
Okay. Thank you very much, Mohammed, for your nice questions. Yeah, really, there is a contradiction. As well, there is also a paradox, as you raised in your questions. But I think one of the problems in the Nile region is the politicization of the Nile water. This is as a result of one is from the traditional siloed approach. On the other hand, is the association of the Nile water to geopolitical and identity issues, which has been nowadays a challenge to the Nile operations. So as far as this is concerned, I think the politicization of the Nile water, the consideration of the Nile water as a matter of identity, as a matter of geopolitics, and so on, is structural defects or structural factors or impediments to the Nile cooperations. But I believe that one solution is the depoliticization of the Nile water through the Nile Basin initiatives and through other technical forums like the Nile Basin Discourse Forums and so on. We can approach Nile from the technical point of view. We can depoliticize the Nile issue. Then we can move from technical to political and other issues. This is what can be called a reversal trend to the Nile regions, from politicizations to depoliticizations. Again, there is also a need of desecuritizations of the Nile water through the Nile Basin initiatives and other issues. This can lead to the ratification of the Nile River Basin Cooperative Framework Agreement, as well as the establishment of the Nile River Basin organizations, which will be a remedy to the structural defects. At the same time, the financial constraint has to be also mentioned. I mentioned the colonial legacies as a structural defect. As far as my knowledge is concerned, one of the structural problems in the Nile River Basin is the colonial legacy, which impacted the development of water resources in the Nile region from the equitable point of view. But still, the finance is coming from those colonial powers, or from those countries who formerly colonized the Nile regions. So they just set a bad precedent to the Nile corporations during the 19th century, for instance, the Great Britain. Nowadays, we are also approaching them for finance and so on. So still, this also be a challenge for the Nile Basin initiative. As financial constraint is a major problem. So what I see is that there is a need of international cooperation and collaborations, mainly on the technical parts. And the Nile Basin Initiative and other parties can work on technical issues through depoliticizing and desecretizing the Nile water. This will gradually lead us to the formalizations of, or institutionalization and legalization of the Nile River Basin issue. I think this is my reflections. But as you mentioned earlier, it is something a paradox and polemical. Thank you.
Okay, thank you very much, Gashau. And again, there's a quick question to you before we close this session, before we go to something else. It's saying, are you saying, Gashau, are you saying a hydropower energy development will not be successful as it should be if nations work by themselves to secure their food, environment, etc., or all countries in cooperation?
Yeah, I think it will not be successful in a way to ensure sustainable development goals in the Nile River basins, or to bring sustainability in the Nile Basin. Even it also risks the sustainability of the Nile River Basin itself, because nowadays we are witnessing a unilateral hydropower development in the Nile regions. This is, I think, a challenge even to the ecosystem of the Nile River basins itself. Again, it can be also a source of tensions, hydrotensions among the riparian countries. Take, for instance, the hydrotensions between the Ethiopia, Egypt, and Sudan on the Grand Cape and Renaissance Dam. There might be also other hydropower tensions. This is largely due to the unilateral approach of hydropower development, which is largely from the traditional siloed approach. Again, within the state, there might be also conflict among sectors, among the water sector the energy sector, the food sector, and the environmental sectors. If you see also from the cross-border perspectives, again, there will be also conflict among countries of the region. So the only way out, I think, is to approach the Nile investment as well as the planning of water resource development from the water, energy, food, and environmental security approach by recognizing the trade-off and the synergy among the four sectors: the water, the energy, food, and environmental sectors. Otherwise, it will lead to the hydro tensions among riparians, and within the state even there will be a conflict between and among different water resources, between the central government and the local communities, again between the energy sector with the water sectors, because each sectors are using the water, yeah. So this will affect the development of the river. Even it will also affect the ecosystem of the river itself, because there will be a competitions. If it is a unilateral development, there will be competitions within the state as well as across the state. So it will not be successful if you see from the perspective of sustainability and so on.
Thank you very much, Gashau. And before we end our session for today, we are going to have some bit of more panel discussion on the general questions. We need to reflect on some few issues, and for this, I'll expect to get some input from all the presenters. And we have 3 questions which we are going to reflect on. The first one is, what tools and data sources are required in the Nile Basin to support strategic water resources assessment to achieve equitable utilization by the countries? And the second one is going to be on the approaches which have been used so far in the Nile Basin and what are their strengths and weaknesses. Maybe let me start with the first one. And it's about the tools and data sources which are required in the Nile to support strategic water resources assessment to achieve equitable utilization by the countries. Maybe I'll start with Prof. Hubert, and based on the strategic water resources assessment work you are completing now, and then I'll also go to Jensen, if you can have some reflection on that, and then also to Mohammed, and then Gashau.
Okay, thank you very much. So the first one with the tools and data sources, our lesson learned is the following. When I look at the workflow that was established within the SWRA process, a critical point was really the workflow on data collection until data is transferred into something digestible for a modeling approach or any other approach. And here, the weak point is that this workflow is not yet fully established because of 2 reasons. The first reason is data formats. There were, we tried at the beginning, in phase 1 actually, without me. In phase 1, there was an attempt to create a standardized data format for data updates, for data delivery from the countries. And that means if you have a standard, and then you have a clear terminology on terms which are essential so that everyone is really on board on the same page, that would really help. But that was not fully implemented. And the response was diverse, to put it this way. It was not harmonized. At the beginning, the attempt was, yes, we want to harmonize things, but the response was not harmonized. But this means that there is some risk that information is not fully understood, because when you divert from some standard which was agreed upon at the beginning, and then you go into some different direction, then the response is not clearly, does not meet what you said at the beginning. I mean, misunderstandings can really happen, and the workflow is impeded. So that is one thing. What tools and data sources? I would say a tool means to have a clear workflow on data exchange for this kind of assessments. so that future plans in terms of irrigation, that parameters which are needed for all these modeling exercises, that this must be clear in terms of the terminology and definition must be clear, and then how to prepare this and how to bring that back to NBI. I know that NBI had spent a lot of effort in harmonizing that. And another thing that we really found as a lesson learned is, and where we are now working on, is we need a platform that brings all this information together, including climate data. And the climate data means it must not stop in the year 2018, for example, because it's a static data set of temperature and precipitation. We need a dynamic approach so that, for example, satellite estimates on precipitation and temperature should come in automated so that the climate data we have increase over time. Currently, any assessment gets stuck at end of 2018 because that was the last day when climate data was refreshed. And now we are working on exactly this, that it is possible to increase this continuously so that a model run can run up to now. And what we also found is when we offer now, that will happen in the next few weeks, when we start this common data platform based on the SWRA data, it must be based on a minimum internet connection. We faced so many problems with stakeholders when we had meetings and when they tried to download things and it was not possible. And to keep a permanent internet connection because of some license issues, we stopped that fully. And that means we need only minimum internet connection where you grab your information and that's it. And the rest should go as a standalone environment. So that is my first, my response to this question first. So we are on the way in bringing that to the participants, to the countries. This is planned by this year to have an inception workshop on how to use this new common data platform on SWRA. We are just preparing that together with NILSEC.
Thank you very much, Prof. Jensen, do you have some reflection on that?
Yeah, just very briefly, I think the very interesting presentations we've seen today just highlights the needs for a wide range of tools when you do these types of assessments. It goes all the ways from water balance tools, water allocation modeling tools, but also analysis tools for time series and spatial data, tools for converting some of these data into indicators, so indicator management tools, because at the end of the day, decisions will be made on indicators which are compiling climate, hydrological, socioeconomic, and environmental data into key decision-making indicators. Multi-criteria analysis tool for identifying investment opportunities, trade-offs for development scenarios are also so critical. On the data sources, just to touch base on this with the EU-based or satellite-based climate data, this is default nowadays. We are always using satellite-based climate information. It's also available at NBI through one of the previous projects. So this is a default data source at the moment. With respect to the internet connections, there are a lot of countries still struggling, but we also see a trend really going towards having very stable mobile-based interconnections in many African countries now. So I see that the issue with having internet connections is really getting smaller and smaller. The development is going so fast in many African countries. Yes, that's what I have to say. Thank you.
Thank you very much, Jason. And I'll go to Dr. Mohammed. Dr. Mohammed, you have talked about something very interesting on the emerging issues, technologies in terms of artificial intelligence in the water resources planning framework. What is your reflection on these questions?
Thank you very much. I think artificial intelligence is going to be, at least this is my projection, is going to be the way water resources managed, water resources systems are planned in the future. And the reason why they are this way is because you have separation between your simulation models and between the optimization algorithms. This is not like mathematical optimization that we knew in the past, in which you've got everything together, but you've got a simulation model, which all stakeholders can work on together and try to come up with the best way to represent the system. But then you've got the AI algorithm, which just talks to the simulation model many times and then figures out the best way to operate the system. So I think this is something that we need to start using in the Nile Basin, and I think it will, in addition to its ability to provide us with good solutions, I think it can also promote a sense of togetherness and sense of collective management of the system, because you can represent different objectives of different stakeholders, different countries, and at the same time, these different countries can also work together on the simulation and tools. One thing that I want to talk about in terms of data, and I think once we start talking about climate change adaptation, it's very important that we always not use one climate change projection. I would even say don't use 2 or 3, because the uncertainty is huge, and you could just use 2 that represent a dry future or 2 that represent a wet future. Try to use a wide range that capture the entire range of uncertainty, and then also go through all the due diligence of bias correction and downscaling and everything. And it would be great if we could have a database like that for the Nile Basin, publicly available for everybody, to be able to use them for future planning. In terms of tools, I think it's also important to have, so there's this spectrum between having a black box tool that you just give it input and you get output, and then you've got a very transparent tool where you have even access to the source code and you can understand what the tool is doing exactly. I think going for these 2 extremes might not be the best way to move forward. I think we need something in the middle, because if you go for a black box, then you lose the confidence of users, and then if you go to a fully transparent tool, then you run into the risk of not being able to track who is doing what and all the changes that are happening to the systems and to the models. So I think we need a tool that's in the middle, provides transparency, but at the same time is not a black box. Yeah, these are the points I wanted to mention here. Thanks.
Thank you very much, Dr. Mohammed. Gashao, do you have any response to this? Can you add something on that, on the issues of data and tools? You talked about water, energy, food, and environmental nexus. In order to model this system, what kind of data and tools do you think are really relevant for the strategic water resource management?
Okay, I think the issues are raised by other speakers. So I have many other issues to be added. I think the nexus one is additional to for strategic water resource management in the Nile River basins, which I advocate. As the rest, all others are mentioned by earlier speakers, and I agree with them. Thank you.
Thank you very much, Gashao. Okay, and now the last one is, I think Prof. Hubert has already mentioned some few steps, is on the steps, preliminary steps which are required which has to be undertaken, some initial steps which have been to be undertaken before undertaking a full-fledged strategic water resources assessment in the Nile River Basin. From the experience of work which have been done, maybe Jason, if you can also say something on that. Hubert, I think, has said something. If you have additional thing on that, I can come back to you again in the next few minutes.
In respect of time, I will be very brief here. I think one of the most important things is really to compile and quality control all relevant information, and especially the quality control part I see as one of the most important steps, meaning to identify what are the gaps, and especially also make some kind of assessment of what are the uncertainty related to any decisions that we take based on the information that we have. Because often there can be a lot of information available, but even available information can actually lead to misleading decisions based on the quality of the data. So I would say quality control of data is one of the key steps as I see it. Yeah, I will stop here.
Thank you very much, Jason. Prof. Hubert, do you have any additional thing on that? Or you already exhausted? Thanks.
No, just one remark from my side is what I see, there is a parallel ongoing program at NILSEC and in the whole Nile Basin, and that is the monitoring. Monitoring program is really developing further, and monitoring here means we have precipitation monitoring sites, we have that means meteorological stations, and we have discharge stations. So as far as I know, discharge stations will not be shared. So because there is no sharing agreement, data sharing agreement yet in place. As long as that is not in place, the monitoring will just be useful for country by country, but not from a viewpoint of the Nile Basin. But it may be different when we talk about climate stations, meteorological stations, precipitation and temperature, and that would really help, because when we get this information and when we are able to link the monitoring program with the common data platform of SWRA, that will inform the climate time series and will really help to move ahead in bringing a step further from modeling. Because what is currently developed at the NILSEC, for me, makes absolutely sense to link in the best possible way. Otherwise, the question is, why do we do that if all runs parallel or maybe somehow in a competition? So that is what I think would be an absolutely positive step when it's possible to link these products, which are currently under development, to link these products together. That is an asset for me, a strong asset, absolutely. And of course, would maybe help in the way forward of data exchange between the countries as a side function. Thank you.
Thank you very much, Prof. And Mohammed?
I mean, not much to add, just echoing the importance of data quality, because you know, while I was building my model, I was also looking at old models of the Nile, and there's this something that we always say: data has feet. So once you start modifying data and doing quality control on an isolated basis, you start diverging over time. So when you look at old models, you often see different data that are used in different models. So I think there's a need to harmonize everything, and I think the work that Professor Hubert is doing is quite important. And I think this needs to be done at a better scale, and the data becomes available for everybody so that everybody is using the same data.
Thank you very much, Dr. Mohammed. And Gashau, very quick reflection on that.
Hello.
Yes, please,
Hello.
Gashau.
Yeah. Because of internet problem, can you please repeat again the question?
Okay, the question is, we have looked at the issues of data required and approaches which have been used in the Nile River Basin. So the question is, what could be the preliminary steps that should be taken before undertaking a full strategic water resources assessment in the Nile Basin?
Okay, I think the priorities, but I think we should focus on the national institutions first. There should be a cross-institutional cooperations and a strong sectoral linkage at the national level first. Even at the national level, there is no strong data sharing platforms and so on. Then we have also strong cross-sectoral, cross-border and cross institutional cooperations at the basic levels, which has to be again focusing on technical matters, on technical issues, because the political willingness and the commitment is not there in the Nile River Basin countries because of the politicization, separatization of the Nile water. So there should be a focus on the technical matters, on the technical issues. For instance, the Ministry of Water with the Ministry of Water and Energy of other core-riparian countries and so on. And within the state, there should be also cross-sectoral cooperation. I think that is the prerequisite first.
Thank you very much, Gashau. And I think this brings us to the end of our presentation session today. And it was really a great session. Thank you for the great presentations and for the great discussions. And I think it was really very interesting and very informative. Before we close the session, I'll take it back to NILSEC, to Dr. Mudadir, for further announcements. Welcome, Dr. Mudadir.
Thank you. Thank you very much, Professor Joel, for this outstanding moderation for this session about strategic water resources analysis, a planning tool for meeting multisectoral water demands in transboundary river basins. Thank you for the excellent moderation. And also yesterday, you also moderated excellently also a session. Thank you very much for your active participation in this 7th Nile Basin Development Forum. Maybe just before I go to the panelists and the participant, there was just a small comment about the donors. Just a small reflection maybe here for MBI, the Nile Basin Initiative. We have an excellent kind of support, and we call them development partners. Actually, we don't call them donors. We call them development partners because we receive both technical and financial support in different projects here at MBI. This is just, for example, from the World Bank, from the GIZ, from the UNGF, from the FDB, and other development partners. So we work smoothly and closely with those development partners in different projects, and they supported the MBI, I can say, from scratch up to now, and they are promising us also. We recently met in Sweden with all our development partners, and they confirm also their support to the MBI. This is just a small reflection because there was also a discussion on this point about the donors. But also back to this interesting session, allow me to thank all our panelists here, Professor Hubert, Dr. Olof, and Dr. also Mohammed Bashir, and also Mr. Gishau for their informative and outstanding presentations. I would like to thank also all our participants for their active participations and good questions also. And from the side of our panelists, they responded, I think, very well to all questions. And also in the panel discussion, we have very active and interesting panel discussion. Thank you very much. And allow me to thank you again, Professor Joel, for your excellent moderation and also active participation in this 7th Nile Basin Development Forum. Also, from our side here, we have a team here at NILSEC. I have Patrick, our IT specialist, Marushka, our communication expert. We have Vincent. He's our senior water resources specialist. We have Tola from the GIZ, and we received also a lot of support, technical from him also. We have here our young professionals, and we have also our 2 consultants who supported us like maybe 2 months even before the starting of this NBDF, Dr. Azza and Mr. Suwaid. Thank you very much. And allow me also to advertise for the coming session. Also, there is a very interesting session on the 2nd of October at 9 a.m. And the session, it is about cooperation for development and operation for climate resilient regional water infrastructure. This is also an interesting session. We are planning for this session, as I said, on the 2nd of October, on Monday at 9 a.m. on the same time. Thank you all, our participants and panelists and our moderator, and see you soon in other sessions. Thank you and bye-bye. Thank you.
Thank you very much. Bye.
Bye.
Thank you very much.